Hey everybody, am I actually live? I've put the wrong link, by the way. It's not this one, it's this one. Let's see if it works. Let me check on Discord. Let me check here. There is a lot of latency with the stream. I think nobody's looking. What do you want? So let's see, display capture, yeah, okay. That's it. Okay. So if everybody's here, please give me a shout. Write something please in the chat. I have no idea if this thing is actually working. Hey Astrid, can you go on my website and see if I'm actually streaming on YouTube? Danke. Hey, is everybody here? Can you actually hear me? Can you actually see me?
Yeah, live now, I see it.
Can you write something in the chat though? Oh, Michele, hi. Can you actually hear me? Nice. Hey everybody. So this is actually my first streaming on YouTube. So it's going to be a bit experimental. Hey everybody. Cool. Let me do one thing. Let me put like the webcam. Where do I actually have it? Sorry, a bit of coughing thing. Let me check my webcam. Where do I have it? So my files, my stuff, my data, desktop temp, camera up, exit. So, okay, open. Okay. So can you see me? Let's check. Nice. Oh, there's already quite some people. Cool. As you can see, I have a bit of coughing. But hopefully it's not going to get worse and disturb the streaming. Okay, cool. So, how is everybody doing? Just write me something. Oh, did he stop? Did he actually stop? Hey Astrid. Can you check? Oh. Okay, no, we are still going. Yeah, at home, yeah, me too. I'm basically... Oh, cool. I'm basically in self-imposed quarantine here in Berlin. Yeah, I know there is a big delay. That's because of how the YouTube streaming works. And I think also my connection is not the best as well. Oh, okay. Let me check if it's actually using the right microphone. Seems good. Seems good. There should not be any feedback. Huh. Yeah. Yeah, better actually to stay home in these days. But we got a chance to to do a lot of max stuff, right? So is everybody... I'm actually not hearing myself, so there should not be any feedback. So I'm not hearing myself, so it should be okay from this point of view. Is everybody having the same problem with the audio? Oh, okay. Maybe let me put the microphone closer. Test. Let's diminish the gain a bit. Test. Well, it's not so spacious actually. It's not really big. It's like 6 square meters or something. Okay, cool. Thanks, Matt. Okay, so well, we can start patching some stuff. Cool, there is already quite some people. Nice to see you guys. I was already wondering if somebody would have shown. But yeah, I'm ready to, I don't know, let's do some stuff. Let's throw some input in and we can see what we can do. Okay, so if you got like questions, better if simple ones. Also difficult ones are good, but then I'm not sure I can help. Let's give it a try. So if you got some stuff you want to talk about, just write it up. In the meantime, I will sip my tea. Is it actually stopped? Not receiving any new stuff? Oh, the shader, yeah. Yeah, the shader stuff requires a bit of knowledge about how coding in general works. But for that I also got some tutorials on JavaScript, right? Actually... yeah. So I was actually organizing the tutorials right now in a different way, so that they are organized by topic, but I still have to finish that. So if we go into all, I actually got some tutorials that have to do with JavaScript. Like for example, learn to code with JavaScript on something like that. And this could be a good introduction for stuff about, for getting kind of an introduction into coding. Of course there are a lot of tutorials online already. Audio-reactive blend. Oh, that's nice. This could be interesting. Like a blend. Okay, that's something good. Let's see if we get some other stuff. In the meantime, I will start to create like the JIT world, the context, the usual stuff. Can you actually see the patch clearly? Is this good resolution? Okay. In the meantime, then I will start to create a JIT world. So let's call it live. Is it too small? Oh. Okay. I think if I make it bigger, then the delay will be even bigger. So I would prefer not to make the delay bigger and just keep it if I can make it bigger on max, then I would prefer to do that. Okay, I think it's kind of okay. So let's give it a floating attribute, so it will stay on top. Let's give it a window size. I don't know, window position, all the usual stuff that we usually do. Oh, okay. On mobile, it's fine, cool. So the window position, sometimes when people open my patches, they don't see any window because it's probably too far right on the screen, because maybe I put something like that. So if that's the case, just remember to put the window on a smaller X position. I think I have it on, yeah, exactly. We will use GL3. That's a good thing to point out. So let's actually write it here. GL3 is on. Actually put it a bit like 1200. Okay. Okay, so I got GL3 on, and let's see, let's also, okay, let me save it. Live 01. And oh yeah, don't ask me about MC stuff. I don't know anything about this stuff. I'm a visual guy. Only know about visual stuff. So honestly, I don't know anything about MC stuff. But there are definitely better people on the internet that know about these topics, and I think there are some tutorials around. I'm sorry, I really cannot help much with that. So what I can help with is with visual stuff, but audio, I will gonna let you down. I'm a visual guy, yeah. Okay, so full screen anti-aliasing to keep stuff nice and without aliasing, so this edging stuff. Okay, so what I like to do always is to attach a send metro to the world object, right? So we will keep getting bangs outside of the world, and we can send them everywhere in the patch. Okay, so full screen anti-aliasing. Okay, let's see. It's a good thing to see. Let's give a look. So, for example, if I create a grid shape, right? And there it is. Okay. So let's first put the full screen anti-aliasing to 0. Okay. So let's take a look at this shape. Doesn't look so bad. Let's put it a bit farther. So position 004, something like that. Oh no, -4 actually. Exactly. So no, you cannot really see it very well. Let's first do something like that. Back position 000. Now let's move only the zeta position of this grid shape. Okay. Like for example, do you see these jagged edges on the shape? This little sawtooth thing, it doesn't look so bad here, but if we put the anti-aliasing on, it should look much better. I think, you know what, I think my graphic card already applies it by default to max, so we cannot really see that. Let me check by the NVIDIA settings. Oh, yeah, the pop-up browser is not still supported in GL3, because basically it works in a quite a different way. So that's why don't I have any more the NVIDIA settings? I just updated my graphic drivers, and it seems like I lost the NVIDIA settings. Oh no, there they are. Okay. So if I go here, manage 3D setting, and I go to program setting, and I go into max MSP, okay. So the anti-aliasing is always on, so let's maybe, let's put it off. Apply. Okay. So let's see, I probably need to restart Max as well. So I will close it and restart it again. Okay, so it's starting up. So if you are on Windows, you you have to check also the properties of your graphic card regarding every single program. So for example, for Max, I added that the anti-aliasing is always on, right? But let's see without the aliasing how it looks like. Yeah, that's what I want to see. So you see all these jagged edges. It looks pretty bad, right? All these little sawtooth, all these little steps here. Now, it's not working anymore here because I disabled it from the graphic card. But basically it improves this... Oh, thank you, Bruno. Thank you for popping up. And see you later on one of the... on the future. Yeah, have a good day. Ciao, ciao. So, but can you see all these edges? This disappears with the anti-aliasing, basically. Okay. Now, it doesn't really work from the attribute because I disabled it from the control panel. So let me actually put it back on. Then I'm gonna apply. Okay. Ciao. Let me close Max again and let me put it on. So, music restaurant. Is this clear now with the anti-aliasing thing? If it's not clear, it's totally understandable. Okay, so let's take a look. Now it looks much smoother, as you can see. Okay, cool. GGL pass in GL3. Yeah, sure. Let's give it a look. Let's give it a look just now. Okay, cool. Music restaurant. If it's not clear, just tell me. So let's give it another color to this. Let's make it white. Let's also change the background. So let's create a swatch object and let's say prepend erase color, right? So we can change the background. Let's see. Let's make it something nice, kind of blue. Okay. Right, so let's create a GGL node. And let's draw this grid shape on the node. So instead of drawing it inside the JIT world, we will let it draw inside the node, right? So capture one, and let's give it also to the node the FSAA, and erase color, let's just leave it like that. So if we have to give it a name, of course. So name node. So instead of driving this GL grid shape into live, we draw it into node. Will disappear from live, and it will appear inside the node. So if we output it here, we will have the shape. Output it here, right? Then if we want to display it again on our main window, we can just use a jit.gl video plane, call it live, give it transform reset 2, so it will cover the whole screen, and there it is. If we give it transform reset 0, it will not cover the whole screen, so it will look, not have the same resolution as the screen. It will be just, actually it's just a square. So if we change, for example, if we change the race color here to something else, right, and then we try to if we make this another color, yeah, okay, it's covering all the screen. Let's actually no, okay, let's not mix too many things together. So okay, for the moment, let's just put transform reset 2, and this means that we'll just cover all the screen. Okay. So Nimbin band asked to use the GGL pass. So actually, let me check that I'm actually really inside GL3. Yeah. Okay. So let's use GGL pass. And we have to make this render into Node. Then let's give it a fx name like Bloom, for example. And then we can put this between the object and the video plane and the node. For example, then we can give it the attribute threshold, which means at which threshold the bloom is going to be applied. So if we make it very low, it's going to take everything, otherwise it's going to take only the shape, for example. So it seems to work properly here. Nimbin, if you copy this setup, do you have problems? We can also set the blur weight. So is it working? If you are doing this as well at this moment, is it actually working for you guys? Look, we can make it more. The blur width will set kind of the width of the blur. Let's make it full screen. We look like that. Okay. Yeah, so it seems to be working, and we can want to save these parameters. So we can create a load mass. So every time it will start from these values. "100% white. Are you sure that the grid shape is not too close to the screen? Because otherwise it will look 100% white, right? So you can make it farther and closer. What I also like to do always, let me put it here. What I always like to do is also to create a GGL camera. This one is going to draw also into Node. And then I say tripod 1. Yeah, you can use, so the thing is that GGL pass will work whatever effect you applied on a texture that comes in. So actually you can use it with whatever texture. So you could also say to the JIT world, output texture, right? And then the texture is going to be output from the JIT world object. From here, right? So we could then apply the JIT pass object, GGL pass live. This time it will have to draw to live. Fx name bloom. Let me actually check this. Threshold 0.98, for example. Hi Stefano, always a pleasure. So if we apply this here, you can see, oh no, let me check one thing. Yeah, it's actually already working. So if we say 0.1, exactly. GGL pass works a bit in a, it's not so straightforward. So basically if you draw this to a context, is going to affect the final texture that goes to the screen, even if it's not directly connected to that texture actually. So exactly, so you see it's not connected at the moment, but it's still having an effect on that texture. So it's not so straightforward to use as if you would use like a GGLPix object. Does the hierarchy work if you don't use a context name or other names? Yeah, of course, no, you have to actually use the names, because otherwise the objects will not know to which object to draw, right? Maybe they will draw correctly, but then you cannot be sure the next time you open the patch they will still work. But anyway, yeah, you can attach the GGL pass after the JIT world, for example, or after the GGL node. Or I think you can also attach it simply to a texture. Let me take a look. If you use a texture, I'm not sure, because it can be that the GGL pass is only going to work on the final buffer image that is going to the screen, so I'm not sure this is working like that. But let's give it a try. Oh, Timo! Hi, nice to see you. Nice to see you popping by. No, this is not going to work with GGL pass, okay? So in this case you should use GGLPix and make like a series of GGLPs, but GGL pass is only going to work actually on the final texture that is going to the screen. So let's delete actually this one. And back we are with our little setup. It's working. Okay, cool. Nice. Okay, so I was saying what I like to do is to use the GGL camera, attaching it to a jit.anim drive. How is it called? And then you tell it to listen to the UI, so basically to your keyboard. And then the speed set it to 20, because by default it's pretty slow. And then you can attach this to the GGL camera. And then you can control it basically with your keyboard. So it's pretty cool. Basically by pressing W, A, S, and D, Q, and Z, you can run around into your world, but only if you first click on the window. So if you don't click on the window, this is not going to work. Then if you want to keep focusing on this on the center, you just tell to the GGL camera, look at 000, and then look 1. So it's not going to. Did I say something wrong? Look. Wrote it in a wrong way. Look. Right. Still not working. Maybe. Ah, yeah. Let's do like first an anim reset, just to set it back to the beginning. Bam. No, maybe because I had to draw this then to the tribe. Look at 0, look to live, maybe. Ah, no. The reason is that this object is not in the center. Okay, yeah. Right, because if the object is not in the center, of course, it's not going to look always at the object. But we could give it, for example, the position of the object, and it will always look at that position. I'm going a bit, I'm rambling a bit around, so please bring me back to reality and let's see something more concrete. But then let's maybe change the shape so we can have a better understanding of how we are moving. Some shape cube. Exactly. Let's actually set it to 0. Yeah. So we have a shiny cube in our little world. Let's actually use the same erase color here. Exactly. Okay, okay. Is there some questions about this stuff? Is there some... okay, otherwise we will go to see some Yeah, that's basically nothing actually, but let me pack this into a subpatch. Cool, thank you guys, thank you for the feedback. So let's see some audio reactive stuff, right? So let's do like this, let's create an ads duck, no, ads adc, so the input basically, so this is called easy adc with a tilde character. Let me check if I got the audio input set up correctly. Can I actually use the same input when I'm using the streaming program? Let's give it a look. With meter, oh yeah, seems like it's getting the input. Cool. So this is going to be the left and the right. It's basically the same because the microphone is just a mono input. So we can do several stuff with this audio. One thing that I always do is to just take the amplitude. So we can basically use a snapshot object, which will just convert this audio amplitude into max numbers between -1 and 1. And it needs a bang. So we could also say, okay, do it every millisecond. So we can set a number in milliseconds where it should get basically a snapshot of the audio input, or we can just attach it to a metro and to a bang, and it will do it every time it receives a bang. And since we only care about we only have a certain number of frames every second, we don't want to have more numbers that we can actually use, so it makes sense to attach it to the bang that comes out from JIT world. Okay, so we get basically one number per frame. Okay, we can even plot them. Yeah, I suppose so. Yeah, sure. I never, as I said, I never streamed before, but I suppose there is an option to save the video. So I suppose definitely yes. Hopefully so, but I think yes. So yeah, we can even plot the audio using like multi-slider, and then we can give it like slider style point scroll, or maybe let's say line scroll, so we can attach it here. Yeah, so we can kind of plot our audio input. Okay, and by default the multi-slider goes from -1 to 1, which is actually the range we are using, so this is pretty okay already as it is. Okay, so let's put this stuff a bit below. Let's actually create a sender here, otherwise we have cables running around, so erase color. And let's create a receiver. Okay, so yeah, what we can do is to use a jit.gen and a GGL mesh to modify the vertices of this shape. Okay, that's something that I do in a lot of videos. So the GGL mesh is going to draw to Nodi, and it's going to be of color white. This doesn't really matter. It's going to have auto normals on, which means you will automatically generate the normals which are necessary for the lighting calculation. So in this way, even if it's deformed, even if the shape is deformed, it's going to have the right lighting on. Okay, so auto normals 1. We can also say lighting enable 1. And then we can say to this GGL grid shape, we can say output matrix output actually. So now the shape disappeared because it's not anymore around in the world. It's just outputting its matrix, which we can even see using a JitP window. You can see that this is outputting the matrix containing all the data from the GGL grid shape. And this is a 12 planes matrix, it means it has 12 planes. So we can basically, the first 3 planes, if we use a jit unpack, for example, with like 3 outputs and like we can say jump 3, it means it's going to get, oh yeah, of course I had to set also the other values. So let's first make a jit unpack with only 1 output from which we take the first three datas, which is going to be the position data. Okay, so basically this means the first 3 planes of this matrix that comes out are going to be the x, y, and zeta values of the position of the object. So basically the position of the object in a 3-component vector. And this we can, for example, already send to the GGL mesh, and it will recreate the shape. Okay, it's a bit messed up, but there it is. Then, if we want, we can also send out the texture coordinates, which are the next 2 planes. So we can actually have to set an offset here, 0 for the first 3 planes, and then we want to jump 3 planes further, so let's put an offset of 3. Because, let's see. If I use paint to draw this thing out, like we've got, let's replace a position, then with information, do other planes have then what information? Exactly. Yeah, let's actually write this down. So the first 3 planes are the x, y values of position. So plane 0 to 3. Then we have plane 4 and 5, which is the texture coordinates. Then we got 6 to 6, 7, 8, which is the normal coordinates, normal values. Normals values, also x, y, and zeta. And then we got 9, 10, 11, 3, 4, 5. No, actually, sorry, I got it wrong. This is 0 to 2, this is 3 to 4, this is 5 to 7, and this is 8 to 11, 8, 9, 10, 11, which is basically the color value. So the RGB and alpha. Okay, does it make sense? So if we say offset 0, it means that we are getting the first 3 planes, because we say jump 3. If we say offset 3, it means we are going to skip the first 3 planes, and then we say jump 2, which means give us 2 planes. So if we output here, if we put another output here, we can see with a JitP window the texture coordinates, which basically look like that. If this object was, this we can delete, if this object was something else, like a plane, for example, like a plane, we can see that the texture coordinates are just going from 0 to 1 on the x and y axis. Okay, so we can basically connect the texture coordinate here in the GGL mesh input where it says text code array. Let's go with the sphere. Exactly. And then if we want to take, we can also take the texture, the normal values. Let's put this a bit up. Can take the normal values, so we have to say an offset of 5, because we skip this time 3 planes. We jump 3, we want to get 3 planes, so we say jump 3, we add another output, and this is going to be the normals that we can then attach to the normal array. But this is going to override the auto normals, because in this case it's going to use the normals that the object provides, right? Oh, my computer is going a bit crazy. Why? What's going on, buddy? Seems actually okay. Probably the streaming thing is a bit taxing on the computer. Anyway, yeah, let's actually not use the normals. So let's create the GGL mesh. And let's attach the jit.gen here. And somebody was, Nimbin, he was saying to use the material. So we can do that. We can use a GGL material. And this material is going to draw to Nodi, and we can attach it to the GGL mesh. And this will make automatically the smooth shading on. Then as you can see, it looks a bit funny because we're actually using the auto normals. If we would use the normal array, I think, no, nothing changes. Okay, cool. Let's say auto normals 0. Okay, so I was actually wrong. When you set the auto normals 1, it's going to override the normals that come in from the shape. Okay. If we don't like the specular light to be so big, we can actually say auto material 0 and then give to the GGL mesh a parameter for the shininess, which is going to make the specular reflection a bit smaller. Okay. Seems that is actually is it so big also because the threshold is so low? Okay. Yeah, so it's kind of to see if you, because the GGL pass is going to make everything that is bright is going to make it blooming with this effect on. So it's basically the shininess, the reflection lights are going to bloom. Okay, but for the moment, let's leave it like this. With the GGL material, we got the jit.gen that we use to transform the position vector. So we can do something like that. So, not GGL material, exactly. Shininess is a property of the object. Is not, I mean, the shininess of the GGL material. Let me check if this actually works as well. Oh yeah, this works as well. So basically we have a shininess on the GGL material and we got a shininess on the object itself. Cool. This I actually never used from the GGL material, but it's actually, yeah, it's actually cool to use it from the GGL material as well. We get a nice specular light. I think we got a bug that basically the light is always on the position where the camera is. I solved that bug once, don't exactly remember how I did it. Maybe I had to draw the camera into Node. This is a bug of the GGL material object, I think. Yeah, the camera is always going to, so the light is always going to be where the camera is. For some reason, yeah, that's a bug. Anyway, yeah, shininess in the GGL material and in the object itself. So what if I actually, yeah, let's actually not modify it from the object. Let's just modify it from the GGL material. Thanks for the input, Matt. This is actually something that I never used. Cool. We can change the diffuse color of the object from the material, for example. So diffuse material is actually called material diffuse, and we can make it, for example, red. Material diffuse is not an attribute. How is this called? Matte diffuse. So not material, but just matte. Okay. Then we can set. Okay, what if I put a small value? Yeah, depending on what. Can you do a height map displays? Height map displays. Yeah, that's actually not really working on GGL material and GL3. You know, I found out that this actually doesn't work on the GL3 package, because, for example, if we go on the help of the GL material, I mean, for me actually it doesn't work. Maybe for you it works. I go into 8 maps, I enable here, and then I send them the matrices here. As you can see, I've got it dark, so we don't get like the bump map light effect. Actually, the 8 map is working, as you can see, because is actually working on displacing the object according to the height map. Yeah, we can actually, okay, let's do then this part. So as you can see, we need to set the height map mode to VTF normals. We need a height map, and then we can connect this directly to the GGL mesh. So let's do that. So we can do it yeah, it's basically the same thing I wanted to do with jit.gen, but we can do it also with using the height map from the jit.gen material. So let's say here height map mob utf normals, and let's give it height map. So height map input is one of those normals, environment, ambient, emission, specular. Height map is here, height map. So for example, if we use an image, let's create a jit matrix, and let's say import movie, which means actually import image. Don't know why it's called import movie, honestly. Then bang, and then we can use this as the height map. So let's input an image, screenshots, let's input, let's take for example this, and this should be banged. Let's create a GTP window. Yeah, okay. And okay, let me activate that. Yeah, it's working. As you can see, it's basically distorting the object according to the height map. Sadly, it's not applying the diffuse. Maybe because. So why did it got black? I'm not sure if this is a bug or this is how it's, or I'm missing something. So let me go back 1 second in the help file. Okay, let's actually set this to automatic 0, so it will not continuously output the matrix with all the data. Let's create a bang so we decide when to output it. Okay. And let's let's do like that. Let's create a GGL text so that we will use as the diffuse image. So let's just give it a default image of white, and let's make dimension 512, 512. Suck. Why don't you work? Maybe the normals, it doesn't like the normals. Suck. Sphere. Okay. Why is it actually not appearing? Maybe I have to set. The diffuse is red. Let's maybe make it white. Suck. I'm not sure if this is a bug from the GL3 package, as I said already, or am I doing something wrong? So let me actually check again the help file, because in the help file it seems to be working. So we got simply, maybe the image must have rectangle 0, but I think this is the default. Maybe we need one. Let's do like this. Let's put this inside a JIT matrix. Maybe it's an issue with the light. Could be. Let's first try one thing. Let's give it a 4 char 512 adapted 0. So let's put everything. Everything at 512 by 512. So let's make also this shape to output 512 by 512 vertices, which is a lot of vertices. And no, still not working. Why? Let me create a jit.gl light. The light is never drawn inside the node, it's always drawn inside the main context. So the auto tangents one. Oh, that's right! That's right, thanks Timo. I'm happy that you're here. looking over us. Timo, oh yeah, that's it. Thanks, Timo. Timo is the best. So yeah, it's actually working. Let me check one thing then. Maybe it's also in the help file here. Why is this actually not working? Maybe I do have to. This should. This should work like it is actually. So the auto tangent. It's basically when you do this bump mapping thing. Basically, it needs something called a tangent to create the effect, to calculate the normals in the correct way, and to get like the light calculation. So it expects that the object sends it something called a tangent, which is oh, good to know, Timo. So the tangent is just something that you need to do this calculation. Not exactly. It's something I also studied this stuff, but it's some years ago. And basically, you need to calculate the normals in tangent space in order to have them correctly applying the bump map effect. So it needs the object to pass it the tangents, and this we can do by setting the auto tangents to 1. Okay. Oh. Here I am. We can actually close the camera because anyway you're not seeing me at all. Okay, cool. So yeah, it actually works. Let's try to import another image like this one. Why? Yeah, because maybe we can use this image as actually the texture. Yeah. So there we go. Let's say auto normals 1. Why is it set to 0? Pum. Okay, I think then we can control also how much. We can also control how much the effect is applied. So let me check how we do that. I forgot. We can do this by. Basically by multiplying the value of this matrix. So we can do something like that. Let's actually set this to float 32. Let's put this stuff down. Yeah, I don't know. I'm actually not sure why we can see the back of the object. This is also kind of a little bug. Anyway, we can use a jit op. Multiply and then multiply by like some value, and zack. Oh, it's not really applying anymore the height map. Why? This happened after I did auto normals. It should actually be okay. So why it's not applying it anymore? Timo, if you see something that I'm not seeing, please jump in. Am I still actually sending the image? No, there is something wrong with this jit op. Yeah, exactly. Actually, should write like value 3. Okay. But still, it's not applying the height map. I think it must be actually. I think it must be a black and white image. So we can go jit RGB to Luma, which will create a one-plane black and white image. This match type. Because this needs to be char. Okay, then let's say char. Zack. Let's see what we get out of this. Yeah, this should actually work. Don't know why it's not working. Let me check the help file again. Dim, matrix output, scale, position, auto tangents. Maybe it doesn't like the auto normals, so let's set the auto normals to 0. Suck. Okay. So if we make this number bigger, no, that's not really much happening. Why? Map. Oh no, actually it doesn't need to be a black and white image. That's what I thought it needed it actually. But okay. Let's just for example the mode. So instead of UTF normals, message val, Michele, what are you referring to? Ah, you mean here? You mean here? Yeah, probably, yeah. Like that, right? So let's see. Suck. No. That's not really doing it. Doesn't seem really to be doing it. Maybe let me remove this GTRGB Luma pump. Ah, there we go. I think there we go. Let's make this back into float 32. Oh yeah, there we go, because it was actually capping it to the char amplitude, so it was not working, but now it works. Okay. I ask myself why they only going in this direction, and by the way, it looks like the auto normals is breaking it, right? Because if I say to that auto normals, yeah, it kills the effect. So no auto normals on when you use the UTF normals map. Probably because it needs also normals map to come in at a certain place. Yeah, here. So it's basically not going to work if you use auto normals. I've actually created a bump map generator object that can be used with the GGL material. It basically just generates normal maps, bump maps and normal maps, and on this texture that you can apply inside the inputs of the GGL material to create the bump mapping effect. But I still have to test it with GL3 actually. So okay, let's actually, so this was one thing, okay? Let's actually disconnect now the UTF normals. Let's not use the UTF normals mode. So 8 map mode, let's just say, what if I use the parallax? It needs a normal texture, of course. UTF just does that. UTF normals does these. Okay, let's actually not use that at all. So let's for the moment just keep it like that. Somebody crashed. This can happen, yeah, because this stuff is a bit. In a way, the GL3 package is still experimental, so you can definitely crash when doing these kind of things on the GL3 package. On GL2 it should be pretty okay, but of course there is possibility that it will crash. So okay, instead of using the normal maps, the UTF, the height map, I usually do this thing using the jit.gen. So we can, for example, let's delete this texture, we don't need it. For example, we can use a jit noise 3 float 32 500. Let's just 20 by 20. Or let's make a number, a multiple of 2, so like 64 by 64, or maybe 32 by 32. So if we set this here, And then bam, let's actually set the automatic back to 1 here because we want the shape to be continuously output. Okay, so if we do that, it's just going to sum the noise to the vertices of the shape. Let me actually reduce these dimensions because this is really brutal to use 512 by 512 vertices every time. So yeah, let's do it like that. 200 by 200 is perfectly fine. So yeah. Okay. So what we can do then, instead of simply summing the noise to that, one thing that I like to do is to basically multiply the noise. If you're working with a sphere, for example, we can, let's actually set the shape to sphere. Before it was cube. So if you're working with a sphere, if we multiply basically the output of that for the noise, oh, and let's set this to automatic 1, okay. We basically get every vertex is going to be multiplied by the noise value, and it's going to be bigger or smaller. We can also set the value of the noise, and then add, for example, an offset in order to multiply now the vertices for a smaller value, for example, from, so they can now only go between 1 and 1.01, right? 1.1 to 1.1. So we basically have just a slight change on the vertex position. Let me check if somebody's still watching us. Okay, we have 10 people. We should be cool. It's actually pretty a lot. So yeah. Or what we can do. Yeah, that's basically what we can do. So we can, for example, create a parameter and call it distortion, just dist, give it a default value of 0.1. And then we can use this instead of that. And then we can, for example, control it using the audio. So let's do like that. Let's get the snapshot here. Let's say send audio. Yeah. Apparently a send is slower than a cable. This I've learned. So in most cases you will like to prefer to, when stuff must be sent fast, you will mostly prefer to use a cable, but I hate to have cables running around in the patch, so I will use anyway the sender and receiver. And then we can say prepend dist, and basically this is going to be our distortion value. Now this value goes between -1 and 1, so we probably want to take the absolute value. Right? And we want to connect it to the jit.gen. And now, when I talk, this goes bigger. When I'm silent, it just stays like this. So we can also like multiply this number by 10 just to make the effect bigger. Test, test, test. Yep. And now it's really going mega fast. So we can, for example, also use a JIT slide after this matrix, and say, for example, slide up 5 and slide down 20, something like that. So let's see. Zack. So when I talk, it will go up pretty fast, and then we go down pretty slowly. Okay, so that's one thing that we can do with the audio and jit.gen and the shape. Questions about this? Is it working for somebody? Is somebody still here actually? In the meantime, in the meantime, this message gets to you. I will change randomly color of stuff in the patch. Zack. jit.gen. Okay. Cool, Nimbin, thank you for the feedback. And oh, we can actually still use this image to do something. So let's actually recreate that. Let's actually not set this attribute at all. Let's not set the height map. Let's just send the image as the diffuse texture. One thing we can do is actually, instead of using noise, we can actually still use this image. Oh, and let's actually set the auto normals to 1 because the light otherwise doesn't really work at all. Oh, much better. Much better. With the light applied correctly, this looks much better. Let me... Oh, what do you want? Okay. Just telling me the stuff is not working, but it should be okay actually. So, yeah. This looks much cooler. Let's actually do one thing. Instead of using a noise, let's actually use the image itself. So for example, let's send the image here, and let's say the image. Let's basically use width RGMB, so leaving out the alpha value, and let's take the length of this vector and use that as basically the value to multiply. So let's see if we click here. Okay, cool. So now it will only go out basically where the image is brighter. Alright. It will only go out when the image is brighter. Test. Let's maybe make this light up a bit smaller, like 2. Test. Okay. Prova. Test. Nice. Okay. Why is this getting black? Seems to be again a problem with the no, the normals are working good. Not sure. But okay, it's kind of working. Let's change the image. Let's take something that is more easy to basically see in action. So for example that. Okay, so this will only go out where we have the image. Let's change actually the shape. Yeah, exactly. This is why we use auto normal math. Exactly for this reason, because then the normals are going to be calculated correctly. So let's use, for example, the cube. Test. Okay, it's not really working correctly because right, because we're using the image, but of course the image is only applied where we're using the whole image for the. Why not use the normals from the grid shape unpack? Because they are always going to be fixed, the normals from the grid shape unpack, and we want them to change according to the vertex that come in. So this will not work, right, Timo? Correct me if I'm saying something stupid, but this should be how it is, because we don't want to use fixed normals, we want them to change. So this should make sense. Let's actually try one thing. So if we use a jit.gen here, and we put this matrix going inside this jit.gen, and let's use actually the texture coordinates to actually sample this image. So let's do actually like that. So suck. And let's see what we get as an output. I would like to have like the image applied according to the texture coordinates. Okay, that's cool. This should work. So let's apply this here. Bam. Okay, now yeah, it's kind of working. It is kind of working on 3 sides. It's working. On 1 side, it's not working. Why? Ah, okay, because they're only going to go. Okay, they're only going to go between between 0 and 1. These values, okay, so they will just multiply these values between 1 and 1 plus this. So, no, this should actually be okay. So actually, I'm not sure why this is working like that. So let's check again which kind of image do we get. Only four images. We should actually get 6 because and if I get similar results actually, but my normal theory is not that up to date. Oh, yeah, it will look kind of similar, but this will look better when. So let's actually try. So let's take the normals and connect it to the normals output here, and let's set auto normals to 0. Yeah, so this is how it's gonna look, which is kind of okay, but if we put auto normals to 1, it will look a bit sharper. A bit sharp. Can you capture distorted geometry then add another level of distortion to it? Yeah, of course, of course. You can do whatever. We can do whatever we want. So test. Let's go 1 second with the sphere. Test. First we do that. Let me just do one thing. I would like to actually do that. Multiply these by the sphere and then add it again to the sphere. So let's just do like that. Instead of adding this one here. Test. Prova. Test. Okay, that's basically the same. It's basically actually the same. Okay. But okay, let's leave it. No, let's actually go back as it was before. Okay, cool. So yeah, we can actually, for example, add another input here, input 3, and we can then use the noise. We can then apply the noise on that. Or we can, for example, we can switch the x and the y and the zeta. And then we can, for example, recreate this shape, but instead of just using the coordinates as they are, we can, for example, use the cosine of the y. Then multiply maybe the y by 10. See what we get. Maybe, no, let's do the same thing, but with the zeta. Let's see what we get. Test. Oh, this looks pretty strange. Let's just multiply it by pi, or maybe by 2 pi. Okay. Now the normals are kind of starting to look a bit strange. Yeah. Okay, now it's starting to look a bit strange. Let's actually remove the first distortion so we have a better idea of what's going on. Okay. Oh, nice. Yeah. Let's actually do that. Let's sum that. So let's multiply this by, for example, 0.1, and let's sum it to the value undistorted. Okay. So let's see what we get. I'm not sure why we get some wrong lighting calculation here. Auto normals is on, auto material is off. So what if we disconnect the material? Just let me try one thing. I think I need. Now let's connect the material back. When the normal go in and make patterns, is that just because it's too complex or irregular to light properly? Yeah, that's what I believe actually. Yeah, exactly. Exact amount. Let's maybe create a GGL live type point. Yeah, I think that's yeah, I think that's exactly because the normals are too the vertices are too strange, and it's actually not working properly. Also because we are using this jit slide in between, which is probably not helping on that side. Or am I saying something stupid? No, that's actually no. This has nothing to do with it. Okay, so what if I connect this actually here? We still get some weird results. Or this can actually just be how the texture image it's looking. So let me actually use another one. Let's use that. Ooh. Okay. No, the normals are not working correctly at all. Can this actually be because we have the auto tangents on? This would be strange. No, I don't think this matters. Anyway, let's try to focus on the distortion of the shape. So yeah, if we multiply this, for example, by 10, cool. And then we make it a bit bigger, this value, we started to get some interesting results. Okay, let's, for example, I have a lot of fun with that, just modifying the vertices of the shape. You can really go some interest. You can really find some interesting stuff. For example, if we clip everything to minus 0.5 and 0.5, then we put it here, we get like a cube, right? Then we can multiply it by 2, so it goes to the original size. And if we just attach it like that, we get this cube with basically clamped. And then we can, yeah, it's a bit crazy. And then we can attach it. Let's not do that here. Let's do it with the epsilon. Zack. Let's multiply by 1. What do we get? No. Okay. No, okay, let's leave the clip away. Okay, so we get this shape here. No, okay, the normals are working actually good. As you can see, we get the proper lighting. Okay, kind of cool. So according to this now, we can, for example, just use this the audio value to modify this number. So test. Let's multiply that by 100. Cool. Yeah, okay, this looks cool. This looks cool. Let's actually add the multiplication. No, let's add it here. Okay. Now let's make like 50. Test. Okay, this looks cool. Okay, what else can we do? This is like a bit wobbling. We can of course make the x dimension bigger, epsilon dimension bigger, and just have a squashed sphere that will wobble around. Let's multiply this by something smaller, and we can multiply this by something bigger. Test. Let's make it really big. Test. And of course, yeah, you can already start to have some funky stuff going on. This could be like some audio-reactive visuals already. Test. Prova. Yeah. This could be one thing. What else can we do? We can still use the noise actually to do some stuff. Prava. Sorry, what does it mean, my friend? Yeah, let's use the noise to... Oh, okay, we can use the noise, you know what? We can multiply this number using the noise. So let's check. Test, 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 test. Da da da. Did I say Prava? This doesn't make any sense at all. But yeah, most of the time I don't make much sense. Test, test, test. Da da da. Da da da. So now it's using the image. Let's actually use the noise. Let's delete that. Let's actually use the noise. Let's use the noise in the input 3. So let's change this to input 3. Da da da. Of course we have to input that. Test, test, test. Test, test, test. Okay, this looks cool. Test, test, test. We can add an offset in order to... Oh, hello, Bradley. Thank you, my friend. So let's add an offset to kind of move these. Test, test, test. Should we actually sum that? Test, 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 test. No, I think we should actually remove that. Maybe. On GGL text is a bit tricky because you first need to output the GGL text as a matrix, which can be done actually. I think Ryan Cravery has a patch that does that on his Patreon, I think, to output the mesh from GGL text. And then when you have the mesh, you can basically just replace the mesh to that, and you've got the distortion. Okay, we can change the appearance of that a bit, playing with the diffuse model. Test, test, test. Let's see, we got yeah, Toon. It's like a bit cartoonish. Mine. So you can kind of see the one that suits you the best. I think Lambert was kind of okay. Let's try to change shape. Let's go with the torus. It's also cool when you change the shape. It kind of makes these sweep between one shape and the other, which is pretty cool. Yeah. So torus, test, 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 test. Can make this matrix a bit smaller. So it's going to test, test, test. Exactly. Test, test, test. Okay, so we use the noise to multiply that. We can actually use the noise to multiply... Oh, it doesn't make much sense anyway to use the length here. Let's just actually switch x. And we can multiply that by... Oh, let's try to multiply that by that. Actually, I just wanted to multiply this by the noise. Test, test, test. Let's do like that. Let's multiply this by some bigger number. Test, test, test. Test, test, test. Prova, prova, prova. Okay. Okay, yeah, we can also add an offset. Test, test, test. Test, test. Yeah. Prova, prova, prova. Prova, prova. Okay. Yeah, and you can play a bit around with these and see which effect looks the coolest. So let's go back to the sphere. Text, test, test. Oh, sorry, I'm not seeing what you're writing. Okay, nothing new. Yeah, of course we can diminish the threshold, so this will be a bit more shiny. Test, test, test. Test, test, test. Okay. What we can do, we can also yeah, sure, I will upload it for free download on my Patreon probably. Sure. Prova. Yeah, prova is like, it means like, it's what the people say when they test a microphone in Italian. Yeah. What did I want to do? Oh yeah, I wanted to not do this distortion only on the z-axis, but we can of course apply it to everything. So if we do that, what do we get? This. Okay, no, it's a bit too messed up. Okay, no, it's a bit too messed up. Or isn't it? Test, test, test. I mean, it's kind of cool, but it's a bit too messed up. So what I wanted to do is to use this distortion. What am I doing? Oh yeah, this goes here. Test, test, test. Test, test, test. Why do you look so different from before? Because this is connected to everything, which is pretty cool. Test, test, test. Oh yeah, this looks nice. If we use the x-axis, also looks pretty cool. Let's multiply this by something smaller, like 5. Test, test, test. Test, test, test. Yeah. Yeah. Okay. What did I want to do? Yeah, I wanted to use the noise also. Like, let's switch the epsilon value. Let's multiply it by the shape, and let's simply sum that. So this regarding what we said before, that you can actually add the layers and layers of distortion as much as you want, basically, because it's anyway going to in the end what it counts is the vertex positions, and this you can play as much as you want inside jit.gen. Okay, so yeah, this looks pretty cool. What is this? Okay, let's do actually like that. This multiplied by 10. Let's see what we get. Test, 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 test. Test, test, test. Okay, see, let's actually do slide down 5. Okay, test, test, test. Let's make it so slide up 5. Test, test, test. Prova, 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 prova. Okay, 10 is a bit too much. Let's make like 4. Test, prova, prova. Okay, let's make this bigger. Prova, prova, prova. Cool. You know what? We can also do that we modify. We use not the x, but like the length of this object to use it as the angle for the cosine. So let's see what we get. Test, test, test. It's not really working. The length of these. Because they all have the same length. Since this is a sphere, all the vertices have the same magnitude, which is 1, of course. So let's try to change object just to see how this looks like. Test, 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 test. You know what we can do? Instead of using the length of the vertices, let's try just to use the vertex of S norm. Yeah, exactly, Timo. Yeah, that's what I just realized myself. So yeah, we can use, for example, the length of the normalized signal normalized coordinates to have a bit of spicing up a bit the effect. Just actually to have a different effect. Actually, so does it look cool? Not sure. Not completely sure. Not completely sure. Yeah, actually not. Now let's go back with the Z. I think was the one that was. Yeah, no problem. My delay. It's very bad. This is just how YouTube works, I suppose. Yeah, let's go back to Sphere, which looks pretty cool, and yeah, I will stop soon. So if there are some final questions of stuff you want to see that is like very short and easy to see, we will do that. So just let me know. I will wait 1 minute for your input. Test. In the meantime, I will play a bit around with that. Diffuse. Test. Test. Can you show us how to record a video? Well, I actually have a lot of tutorials about that. Let's check them out. So, how to record a video? I've got here how to send your video stream from MaxMSP to a Spout or Siphon client. Yeah, no, actually there is something that I don't cover. So good, I had fun and I feel more confident with Jesus Kids now. Oh, that's really great, Nimbin. Thank you very much. This really makes me happy. Bradley, is it hard to map two of these objects together? What do you mean exactly with map the object together? If you mean like mix two objects together, this is depends the result you want to achieve. So we could, yeah, this could be done. Combine two, okay. Yeah, depends the result you want to achieve. I can show you one way of doing that. Let's see. If you hook these up to magnify greatly the GPU use. The thing is that in the GL3 package, they really made this very cool with the GGL multiple. Basically, it just uses the GPU now. And so it's not going to wait too much on your computer because all the calculations are going to be done on the GPU. As if you use two different signals. So you mean like audio signal. Let's first do 1 second this thing with the GGL multiple, which I find kind of funny. So GGL multiple, this is also going to be drawing into Node. And then we can say let's give it 3, let's give it only the position input. So GL params position. Let's actually also give it the scale. So scale. Okay. Okay. No, that all depends how you want to have the final result. So if you want just to sum two audio inputs together, then it's just going to have the sum of the two values. If you want to multiply them, it really depends in which way you want the output to be, basically. I know this doesn't really help, but we should see a practical case. Let me just finish that. So, for example, we can have a jit.gen, and let's use a matrix jit, matrix 3, float 32, and let's say 10 by 10. So we will draw 100 of these objects. Okay. Target name uguale crazy object, and let's call this object crazy object. Okay, let's actually give it automatic 0, so it's going only to be rendered by the GGL multiple. And let's do like that. Let's use jit.gen, let's use sorry, let me make this bigger. So let's use the signet normalized coordinates. Let's switch the x and let's switch the y. Let's use these as the x and z coordinates. Let's attach this here. Let's give it to everybody of them a scale of 0.1, for example. Let's connect these as the scale. Bam. Let's create a bang. Boom. Okay. Okay, a bit too small. Let's multiply this by 5. Let's make this bigger. Bam. Okay, cool. So we are drawing 100 of these objects at the same time, and it's really not that hard on the computer, I have to say. Let me check. So let's go here. We can see that it's using 25% of the GPU, which is it's not too bad, but it's still doable. Let's draw 100 by 110,000 of them. This is going probably to be crazy. That's a bit too much, but you have to think that this object has a lot of vertices, so... No, let's actually stay by 100. Bam. Please, don't crash. Okay, cool. Let's distantiate them a bit, so let's multiply by 10. Bam. Okay, cool. Oh yeah, this is our little army of crazy fellas. Test, test, test. We can maybe make them vertical instead of horizontal by putting this here. Bam. Okay, cool. Let's multiply this by 12. Bam. Test, test, test. Oh, sorry. Test, 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 test. Audio-reactive little spheres all together. Yeah. So summing two audio signals, yeah, we can basically just sum them together at the audio signal level, or yeah, maybe we can see that. Maybe you can see that in a tutorial. Just write me exactly what you mean broadly, and I will see. I will check if I can come up with something useful. So I think we are going to stop here, my friends. It was a lot of fun for me. I hope for you was interesting as well. Thank you very much for joining. This was really nice. I will do this more often. And thank you very much. Thank you very much for being here. So I will wait 1 minute to get your greetings. Then I will shut this out. Thank you, Timo. Thank you, Timo. See you soon. And keep you up the great work as well. Thank you, Music Restaurant. Funny name, by the way. Thank you all, guys. Thank you all. Thank you all, and see you soon. Yeah, stay safe and keep maxing. Ciao, everybody. Ciao, ciao.